Welcome to our project. Our project is path optimization in machining process. Next. So we are three members in this project. Me, Jyotirmay Singh. I did some research on CNC machines as well as I will try to discuss some future scopes of improvement in our project. My friend Alapan Sen, he designed some algorithms as well as worked on the modeling of our project. And my other friend Ayashkanta, he found some application of AI in CNC machining as well as he helped in the optimization of the code. Next. So, we are presenting an approach to generate optimized tool paths for freeform surfaces that are commonly used in automotive, aerospace, biomedical, home appliance manufacturing, and diamond industries. There might be various reasons, for instance, aerofluid dynamics efficiency, ergonomic, or aesthetic incentives for designing and manufacturing freeform surfaces. But recent developments in CAM systems allow manufacturing of complex freeform part geometries. But here we are having a negative point, which is toolpath generation in current CAM technology is still based on geometric computations only. So one of the most critical issues in process planning with CAM is selection of an appropriate toolpath for machining of the freeform surfaces. Next. So we are having a CNC machine, so which is generally known as computer numerical control, uh, used for automated control of machining tools. It works on some codes used in machines such as lathe, mill, drills, 3D printers, wire EDM, etc. Next. So CNC plays a very important role. Even once my professor Aditya Bandyopadhyay sir told us that we can't imagine this world without CNC. So CNC plays a very crucial part. In modern CNC systems, the design of mechanical part and its manufacturing program is highly automated. So computer scientists and data scientists plays a crucial role. In industrial level, the optimized path of the cutting tool is very essential to save time, energy, and resources as well. The resulting directives are transferred by post-process software into some specific commands necessary for a particular machine to produce the component. So our project is to find the optimized path of the cutting tool. So next. So now it's time for you, Ayashkanta.
Thank you, Jyotirmay. Now let's view the problem statement, which says that when an input has been given to a CNC machining machine for cutting pieces of various shapes from a single piece of metal sheet, we have to find the path of the cutting tool for the cutting tool to traverse such that it will give the desired shape and it will take the least time to complete the entire task. Next slide. 11, next slide. Huh. Now let's see the input pattern. We have to give like we are taking a text file which will be included in the C++ code as an input. There are three in the input file. We are taking three types of values. First thing, we are defining the number of points that we are giving in the input, and next for each point we are including three sets of values. The first set will declare to which figure it belongs, and subsequently the next two will be the x and y coordinate. Next slide. This is the preview of a output panel. uh, as I said, the code is written in C++, and the output will basically show us the order of the points that the cutting tool will traverse such that it takes the least time to cover to finish the entire task. Now and Another thing is that we can also see that it is also written here that when the cutting tool will turn on, and it will cut a particular piece. Then it will turn off at that same point because it will travel in a closed loop. Then it will travel aerially to another point, and after that it will again repeat the process for the second figure and subsequently for the next figures. Next slide. This is the let's suppose this is a rectangular panel of rectangular sheet of metal of dimensions 45 cross 20. So we have let's suppose we have to cut three pieces out of which two are quadrilaterals and one is a pentagon. So we can see all the points denoted on the figure in the figure itself, and currently our cutting tool is at the origin. Next slide. uh, from the origin, it will first, according to our algorithm, it will first choose the nearest point. So as you can see, the point with coordinates 8, 1 is the nearest from the origin. So it will first go to that point and start cutting the entire piece of this quadrilateral. And as I said, it will go in a closed loop, traversing all the other 3 points, and it will return to point 8, 1. So after that it will go it will find the next closest point from a different figure, and as you can see here, it is 16, 6. So after that it will go to 16, 6, and it will go through the entire figure, cutting it out from the piece of metal sheet. And next it will from that point it will next find a different point from a different figure, which is the next nearest to it. So now uh, in the next in the next figure we can see that 30, 6, that will be the nearest point from 16, 6. So the cutting tool will aerially cover this distance, and after it reaches 30, 6, it will cut the entire pentagon out, and then after the entire process is over, we can we can assume that the cutting tool will return to origin, uh, but that part is not covered in our program. So next next Alapan will continue with the modeling part. Thank you.
So now let's discuss the modeling part of our problem. So we have used a depth first search algorithm to find a optimized path. So we are using a classical depth first search algorithm. We first initialize the open list with the starting node. Here in our case, that is the origin, and then we initialize the closed list with empty. Then we select the first node from the open list and check if that node is goal node. That means if all points within our given set is traversed or not. Then terminate search algorithm if the goal node n is find. Then print the path of the starting to goal node. Else find the set n1, n2, n3 which has not been traversed yet. Then put n in the closed loop. That means we have already traversed the node n. Then put n1, n2, n3 in the open list. Now sort this open list in ascending order of Euclidean distance from the last closed node n. That means we find the distance from the last closed node n of n1, n2, n3, and then we pick the least distance from the node n, and then we continue from the step 2. Let's understand this modeling with the help of a simple graph. Here, as you can see, it's a simple graph of the sets of some points, and we are going to cut two quadrilateral and one pentagon. So as you can see here, at first our open list is initially initialized with the starting node S. This is the starting node S, and closed with the closed list is empty. Now we put the starting node S in the closed list and find the number of and those sets which has not been traversed yet. So now set 1, set 2, and set 3. These 3 sets has not been traversed. So we put them in open list. Now we find then we sort the this open list in the ascending order of the Euclidean distance that I have marked in at the edge. So here, as you can see, the least distance is 25. That is set 2. So it will be in the front of the open list. Then it's traverse the point set 2 and put that set 2 in the closed list. Now from the set 2 find the which sets has not been traversed yet. Now after set 2 is traversed, set 1 and set 3 is not traversed yet. Therefore, put set 1 and set 3 in the open list and sort them in ascending order of the Euclidean distance. Now, as you can see, 17 is the distance from the set 2 and set 3. Therefore, it is the shortest from the set 1 and set 2. Therefore, after completing the set 2, the cutter will go from go to set 3. That means now closed list has S, S2 and S3, and open list is rest is set 1, which is has not been traveled yet. Now put the now as this element this open list contains only single element, we put that we don't have to sort that, and we put that in closed list, and now our closed list is matching the goal node. Therefore, we terminate our search algorithm. Now let's implement that into our code. So we have implement our search algorithm in C++. So here, as you can see, in our main functions, I am taking the input from the from a text file which is named as points. So this is our text file which contains all of the points that we have to traverse, and we have to cut a desired shape. Then we receive the first number of points which are in there in the rectangular metallic shape. Then we declare a dynamic array of size n plus 1 cross 3. Then we declare 3 variables to store the set number, x coordinate and y coordinate for each point. Then read the values from the file and store and put them onto the list. Then here we traverse to the whole 2D array and check the point is traversed or not. Therefore, we are checking the goal test. If the all points are traversed, then in function main function will complete and execute it successfully. If not, then it's called a move to a set function. Therefore, it's find a nearest set from the current node. Therefore, here it returns the index of that set, and we store that and we revise that initial point with that current with that new set. Then we call the traverse function, which actually put the current node into the closed list. Therefore, it is already traversed. So here pop the points that has already been traversed, and then put and print them into the console. So let's run our program. So as you can see, after running the points, it gives the sequence of the points which has to traversed by the cutter. Now the scope of improvement will be discussed by my friend Jyotirmay. Jyotirmay, go ahead.
Thank you, Alapan. So as I earlier told you, this project is not perfect. It is having some flaws. So with the current model, we are unable to cut out any arc-shaped figure. I mean that if I'll try to if I'll try to cut any arc shape, I mean like this. So we need some infinite points for taking out that arc, but not possible in this case as our machine is going to follow a straight line path. So it gave us a n-sided polygon. And the second flaw is code works to find the shortest distance between vertices only. There might be a case when the point with the shortest distance might not be a vertex. Suppose that my the point of my index finger is a point, and I'm having this pen. If you are able to see it, the closest distance between my point and this pen is this. But in our case, in our model, it traverses through this path, as this is a vertex. So these two are flaws. We have provided you bibliography of our project, so you can go through it, and we gave our best. Thank you.